Okay, we're back. This is chapter 6, and we're looking at 6.2. So we're on page 3 of the note packet. So applications of the normal distribution. So one thing about normal distributions, if you're given raw data, we should, before we make any of these generalizations about the area under a curve, under a normal curve, we should check to see if it's actually close to normal. The data is close to normal. If it's really skewed one way or the other, the mean will be off, and then that'll actually throw off all of our information. And so there are tests out there. There's one that we use commonly, is the Pearson index. The PI, ooh, look like private investigator, fancy. So let's take a look at that. That's, you take the mean, you subtract it with the median, and then you divide it by the standard deviation. Oh, you triple it and then divide it by the standard deviation of the sample. And so let's take a look at page 4. They want to know what's the Pearson index. So if the Pearson index falls between -1 and 1, we usually conclude that it's normal, close to normal. The closer it is to 0, the better, because remember the mean and the median and the mode on a standard normal curve all hit in the exact same spot. So in a truly normal curve, mean, median, and mode are all right on top of each other. And so what the Pearson index does is we take and triple the difference of the mean and the median, and then we divide it by the standard deviation, so by how varied it is. So the closer this is to 0, the better. The overall thing is going to be closer to 0. And the smaller this is, the closer to 0 we're going to get. So let's take a look at this example. They gave us these numbers, 14, 18, 12, 14, 19, 22, 26, all the way up to 24. 17 pieces of data. I used Excel. For that, use Excel and find the mean. Remember, average. I'm rounding to hundredths is good enough for the Pearson index. So 19.65. Find the standard deviation. It's a sample, so that's going to be S. That's not going to be sigma. Remember, sigma is for population. So it's stand_dev.s, and that works out to be 3.76. And so, oh, and the median, remember you put them all in order, so there's 17 pieces of data, so there's one exactly in the middle for the median, and that happened to be the number 20. All right, so now we're going to take this and put it into here, the Pearson index. I mean, 3 times 19.65 minus 20, those are pretty darn close. All over it. You got to remember the 3. It's always 3, so triple it and then divide it by whatever the standard deviation of the sample is. So this one shakes out to be, that's -0.35, and then we triple it, so -1.05 divided by 3.76. And our Pearson index works out to be -0.279. So that does fall between 0 and 1. And so we would consider this normal. We would conclude normal. It's probably a little bit skewed. And if it was really important, I would make a histogram and check out the histogram and see if there's outliers or, you know, any mathematical outliers, or if it's really skewed one way or another. It can be, the Pearson index can be tricked, where it could be bimodal, where there's like a U-shaped thing. Instead of a bump like this, it's like a mode there and a mode there. And the Pearson index will still kind of put it close to 0. And so the for sure way of double checking it is making a histogram, but we're not going to do that. That's if you're actually doing a stats workup on some data, you would want to do a histogram for your study. All right. So Pearson index close enough to 0 that it goes. Oh, also, this is worth mentioning. In different texts or maybe on the internet, if you're using NetTutor or something like that, they might tell you that it's always just between 0 and 1, and that you should always put the larger one first. Either it's the mean minus the median or the median minus the mean. And all you're doing then is making sure it's positive. It won't affect the actual decimal, the fraction that it becomes, and then the decimal. It'll just make it always positive. So then they're only looking between 0 and 1. That's just a different way of looking at it. This particular text has always the mean minus the median, triple it, and then divide by s, and then they put it from -1 to 1. And so, just in case, if you're out there using a different book or something, and you see it where it's always between 0 and 1, that just means they had you fix it so it was always positive. All right. Okay, so let's take a look. Find the probability that a randomly selected American household generates between 27 and 31 pounds of newspaper garbage per month. Okay, so let's do that. So there's a process to this, and it leads into what we did in the first couple of chapters and what we did in 4 and 5. And so we're kind of putting it all together with this. So they want to know the probability that x is between 27 and 31, given that the standard deviation, the mean of the population was 28, and the standard deviation of the population is 2 pounds of garbage. And so what we want to do is we want to convert this into z-scores. We don't want to leave it like this and say 28, like in chapter 4-5 test, you actually did a graph where you kept the raw data, you put the 28 there, and then you counted up standard deviations and made it like 30 and 32 and 34, like that. That's fine, but that's out the window now. Now we're standardizing it, so we want these in terms of z. So we're going to find z-scores. So I do this, or I take z sub 27. And then we use, remember how to find z. Z is your x minus your mean divided by your standard deviation. That's how we do a z-score. So we're going to go 27 minus 28 divided by 2. That's -1/2. That's -0.5. So to many people's relief, you always want to make it into a decimal because our chart's in decimal. So we don't want to really play with the fractions. So we don't want -1/2. We actually want -0.5. Z28. That is going to be, oh no, I'm sorry, not 28, 31. So then we got 31 minus 28 divided by 2. What is that? 3/2, 1.5. All right. And so now we've converted these from raw data into a standardized z-score. So 1.5 standard deviations above the mean and 1/2 a standard deviation below the mean. And we want the area in between there. So we're gonna draw ourselves a pretty picture where that's 0. We got -0.5 there. We got 1.5 there. And we want this area in between. And so now we go back to our chart. Now it's just like back in 6.1. You just look at that up on your chart. 1.50 on your chart has a value of, where am I? There I am. 1.5 is 0.9332. And -0.5 is 0.385. So that's like the 31st percentile and the 93rd percentile. And so this goes all the way down to here. This goes from here to there. And so if we take that whole area and subtract off this area, then we'll have that shaded area. So that's what we're going to do. 0.9332 minus 0.3085. You just subtract those two, and voila, we end up with the correct answer, 0.6247. So that's our z-score. That's our probability, not our Z. We use Z-scores to find our probability. That's our probability. So there's a 62% chance that Americans polled would end up between 27 and 31 pounds of trash in a year. All right, let's take a look at the next one. Find the probability a randomly selected American household generates more than 30 pounds of garbage. All right, so this is going to be almost the same workup, but here, maybe I can squeeze that in. Let's put them both here. So look, probability that X is greater than 30. And so again, we're going to find the Z-score for 30. That's going to be 30 minus 28 over 2. They provided us with the mean and the standard deviation. We're just plugging them into the formula. And so that's 2 over 2. That's 1 standard deviation above the mean. Draw yourself a pretty picture. We want the probability that Z is greater than 1. And so here's 1, and we want this part of it. So when I look up 1 standard deviation above the mean on my chart, I get 0.8431. But look at that picture. No way, that's 84%. That's that little tiny piece right there. So remember that 80.8431, that is this part of the graph. But we want the other part. So we want the complement. So 1 minus 0.8431. And so we're looking at about a 16% chance, 0.1587. So about 16% chance if you selected an American randomly that they would make more than 30 pounds. All right, so let's look at C. We get to do algebra. Oh, we love algebra. So we're going to use this formula again. That's one of the things for you people that are a little bit, not really loving the math. Do not be intimidated by formulas. Formulas are just there, and some of the formulas we use in this course are they're really long. There's a lot of things to plug in there, and it looks overwhelming. Don't be overwhelmed. Just take your time. Put them in and go back to those base algebra skills that I know you have. So on this one, this is one of those where they said, okay, look, I want to know how much trash would have to be, how many pounds of trash would hit that threshold of the 99th percentile. You know, we talk about percentiles sometimes, right? If you have children and you take them to the doctor, they put them on a height weight chart and say, oh, they're at this percentile, that percentile. That's amongst the group. And that's what all of these are in the standard normal curve. These are all percentiles. So look, what we're going to do is we're going to actually use our chart backwards. So let me first write down the formula. So we have this, okay? And we need a Z. We already have that. That was given as 2. We already have that. That was given as 28. They want us to find X, but they want it to match with the 99th percentile. So what we have to do is we have to kind of use our chart backwards. We want to find 0.99 in the body of the chart and see what Z-score matches with 0.99. Well, since I've already done it, I know there's not exactly a 0.9900. There is a 0.9901. And that is close enough. So what we're going to do, let me grab the chart and show you how to kind of work it backwards. So normally on our chart, we are looking up like in a 1.42 we looked up. And that was 0.9222, right? But this time we're going to look in the body of the chart and find 0.99090601 right there. 0.9901. Do you see it? Do you see it? Do you see it? 0.9901 right there. And now we work backwards off of that. And so that is 2.99 2.33. 2.33. All right. So we're going to put that in for our z-score. 2.33. Okay, good. Phew! I thought maybe I didn't have that down on the notes. I was like, oh no. Oh no. Nope, it's there. So 2.33. So that is what goes with the 99th percentile. The z for the 99th percentile is 2.33. Now it's our sweet algebra skills. So you put that over 1. Remember, we cross multiply and solve. So you take 1 times x minus 28. That's just x minus 28 equals 2 times 2.33. So x minus 28 equals 4.66. And now, right, isolate the variable, get the x all by itself, remember, algebra? So add 28 to both sides. And that is our answer. That's what we were looking for. So 32.66 pounds of garbage would put you at the 99th percentile. If you basically made 32.7 pounds of garbage, you'd be at the 99th percentile. All right. Okay, so let's look at, again, with the tech, you can use the tech. If you want to use the tech, you already own a TI-83, TI-84, you can do what's called the inverse norm and plug those numbers in. Again, I caution you that, and on Excel, you can find it on Excel under norm inverse and put in the values. Be careful when you're using the tech, because if you just hit one wrong number, and I don't see any work, you lose all the points. I don't want you to lose all the points. So if you have the calculator and you want to do it, maybe double check it by hand and put that down on your scrap paper. All right. Okay, on to the last problem here, example. As we're aware, daycare costs, oh, they are expensive. Suppose that an annual daycare cost is normally distributed per year. It's a mean of $9,000 and a standard deviation of $1,800. What percentage of daycare providers would charge more than $9,000 annually? So let's do it. So that one, if you're really paying attention, they told us the mean was 9,000. So this is going to provide us with a z-score of 0, which means it's the 50th percentile. And then if we do 1 minus 50, that's still going to be 50%. But we'll work it up. All right, so let's look at A. So they want the probability that x is greater than 9,000. So first we want to find the z-score that goes with 9,000. And so that's 9,000 minus the mean that they gave us. They told us the mean was 9,000 and they told us the standard deviation was 1,800. So we just go 9,000 minus 9,000 over 1,800. That is 0 over 1,800. That is 0. And so if we draw ourselves a pretty picture, we've got 0. And they want to know above that, right? Right. So this is, we're finding the probability that z is greater than 0. Well, that's this area. But when you look that up on the chart, that's 0.5000. That's actually this area. It's from there down. So officially, we would have to do this if we're showing every step, which I am, because these are the notes. And you'd get 50%. But honestly, this would be a case where if you just saw that that was the same as the mean, you could just jump right to the 50%. You wouldn't really have to do all of that work. Although, unless the instructions say show me a picture, then they will. So I guess you'd still have to draw me the pretty picture, but you wouldn't have to show this. All right, let's go with B. The probability that x is greater than 10,000. And so that's going to look like this. We're going to find a z-score for 10,000. So remember, they gave us the 9,000, they gave us the 1,800, and so this is above the mean. So let's see how far above the mean it is. 1,000 divided by 1,800, that gives us a z-score of 0.56. And so we look that up, 0.56. We draw ourselves a pretty picture. So a half a standard deviation above the mean. And we want this area above it. And so when I look up that 0.56 on the chart, it reads off 0.7123. And so then we're going to do 1 minus 0.712. And so that is 29%, 0.288. Okie dokie. So about 29% chance that your daycare, the top 29% are above 10,000 a year. So let's work backwards. So they gave us a backwards one again for letter C. If the daycare advertised it was in the bottom 10% of all daycares for cost, how much would they have to be charging, from what and lower? And so let's take a look at that. So this time we want that, X. They didn't give us X this time. We have the mean, we have the standard deviation. We can find the Z. So we have to find the Z-score that matches with 10%. So that means we're going to look up 0.10, and we'd like 0.1000. That isn't on the chart. So the closest that we got on the chart is 0.1003. And here, I'll show you the chart again. Look that up. So we're going to reverse look that up. It's going to go backwards. We're looking at, we need the negative ones to find 10%. It's below, right? 50%, 10%. So we got where is it? There we go, found it. Right? Nope, did you see my finger? Nope, right there. So 0.1003, and then now look, I'm looking all the way up to the top. That's 0.08. And then I'm also looking all the way to the left. That's a negative 1.2. So the answer for this one, the Z-score that goes with that is negative 1.28. All right? And so now it's plug and chug. We're going to take this, pop that in, substitute that in there. X we don't know, that's our unknown. We do know 9,000, and we do know 1,800, right? They gave us 1,800. And now we use our sweet algebra skills, cross, multiply, and solve. So that means take 1 times that, x minus 9,000, and negative 1.28 times 1,800. So that's where your calculator comes in handy. That should be negative 2304. And now we want to isolate the variable. We want x all by itself. Be careful. Don't skip steps on this one. There aren't a lot of steps in solving this equation, but there's one, and it's kind of important. Add 9,000 to both sides. And then that cancels that out. Lots of students like to skip the algebraic step, and then they just see a minus, and they put them both in as negatives, and they tell me something silly like negative $11,000. It couldn't be negative. There's not a daycare out there that pays you $11,000 to take your kid. All right, so you add 9,000 to both sides, that actually ends up being the difference of those two. And so that's $6,696 per unit. And that would put you, so if you're charging less than $6,696, you're in the bottom 10%. All right? Oh, also, and this might come up, so if you use your tech for this, if you use your calculator or Excel, the answer that you would get with those would be $6,693.21. So it's a little more precise, but again, personally, I prefer to use the chart, and that gives you a better understanding. You kind of get your head around Z-scores are standard deviations above or below the mean, and these are the percentiles that match with them. Where when you're just plopping it into a machine, it's a little fuzzier what you're finding. And so you can use them, and if you get a slightly different answer like that, that's okay, because I also have the same tech, and for my keys on tests, I'll work them out every which way, so you don't get gypped out of, or you don't lose points where you shouldn't lose points. All right? Okay. The next video we'll do is 6.3.